Here we go. Let's get this party started. We got a big factor theorem we're going to get after here tonight. And I tell you what, I think we're going to make it look pretty easy. So first of all, let's jump right into it. Our definition says that a polynomial has x minus a as a factor if and only if p of a equals 0. Okay, and that could also tie into our remainder theorem. We said that if p of a equals 0, then that also implies that the remainder is 0, which also implies that x minus a is a factor. So it's all coming together full circle now, and we're going to focus on this end of it, where we're just saying if a polynomial has x minus a, and I could put parentheses around that if I want, as a factor if and only if p of a equals 0. I think you're going to like these fill in the blanks. We've done some very, very similar to this, and we're just going to start off by saying if p of 2 equals 0, then I know that x equals 2 is a root or a 0 or an x-intercept, then x minus 2, notice the minus, is a factor of p of x. If p of x was divided by x minus 2, guess what the remainder would be? Yep, you nailed it. Remainder would be 0. Okay. Shoot, there's kind of a random stray mark there. Just ignore that. Let's say if p of negative 4 equals 0, then the quantity x plus 4, or the binomial x plus 4, must be a factor. And of course, just for fun, we'd say if p of x was divided by the factor x plus 4, the remainder would end up being 0, according to the remainder theorem. Here's a little trickier one. If p of 1/3 equals 0, who's the factor? In other words, what would you set equal to 0 in order to end up getting x equals 1/3? Try to work backwards. The first thing I would do is I would multiply both sides by 3, and then I would subtract 1 back over, so it turns out being 3x minus 1. And of course, that comes with a little bit of practice, but I think if you took the 3x minus 1 and set it equal to 0, and you could see where adding the 1 and then dividing by 3 gives you this 1/3, and we're just trying to undo that process and work backwards. And last but not least, and modify this, I want to say not equal. What if I told you that p of 5 was not equal to 0? Then you could say x minus 5 is not, I repeat, not a factor of p of x. So again, we'll repeat that. If p of 5 is not equal to 0, then x minus 5 is not a factor of p of x. So when we first introduced you to long division a couple of weeks ago with respect to polynomials, we would say something like this. The dividend divided by the divisor equals what? Our famous Q word, quotient. Now, we can manipulate the terms and move certain things. Like, for instance, what if I cross multiplied? The quotient would be set over 1. We'd cross multiply, and we'd end up getting the dividend is equal to the divisor multiplied by the quotient. And that's how we're going to prefer to write our problems tonight when we get done with our long division. Or in other words, let's think of it like this. If I said f of x divided by p of x, and I told you that that equals q of x. Today we're going to practice rewriting that where f of x equals the product of p of x times q of x. And you can just think of it as cross multiplying. So for instance, here's our first example. I'll set it up like that. So what I'm going to do is I'm going to multiply the x minus 4 over to the right side, and we could say that x squared minus 6x plus 8 is equal to the product of x minus 4 times x minus 2. If, let's see, this would be considered my divisor, this is considered my quotient, and of course this is my dividend. So you notice the dividend equals the product of the divisor and the quotient. Let's try one more of those. In fact, great time to hit that pause button and see if you could rewrite this next example using product only. So I would say my dividend is equal to what? The product of my divisor times my quotient. And we're going to get some more practice with that later. Here's a thought-provoking question for you. How do we find the zeros of a four-termed polynomial? In other words, it's not a binomial, it's not a trinomial, it's a four-termed polynomial. Notice we've got one term, two terms, three, and a fourth term. And how do we attack that? If I wanted to set this bear equal to 0, what are my options? And we've always preached that anytime we work with a four-term polynomial, we're going to use a technique called factor by grouping. And so let's see if that technique holds true here on this first example. We'll group the first two terms. Looks like there's a GCF of 2x squared, which leaves me with 2x plus 3. And then the second group here has a GCF of, I believe it's 32, so I can factor out a negative 32. It's 64 divided by 32 is 2x. 96 divided by 32 is going to give me a 3. And it works out really nice because we kept preaching when we did grouping that this group has to be a perfect match with this group. And now we could say that this group has something in common with this group. And I'm going to factor out the 2x plus 3. I'm going to take it out because they both have 1. And that would leave me with 2x squared minus 32. And then I said, oh my garage, there's a GCF of a 2 right here. So I've got 2x plus 3. Let's see, pull out the 2. That's x squared minus 16. And then the factoring continues because you got a difference of two perfect squares, and eventually you tee it up. Now my next question is, what happens here on this next problem? My first group has a GCF of 2x squared again, leaving me with 2x minus 1. My next group has a GCF of 5, which leaves me with x plus 2. And what we've done here is we've hit a major roadblock, major roadblock. This group right here doesn't match this group. So what we are stuck in the mud right now. We are stuck. Factor by grouping has failed us in this particular case, and that's going to be our theme tonight is what do we do when we end up working with a four-term polynomial where grouping doesn't work, where we hit a dead end and we get stuck. What's going to happen is they are going to give me one of the zeros ahead of time. Okay, they're going to tell us before we start that one of the zeros for this particular polynomial might be x equals 2 or x equals negative 4. And we're going to use that one zero to go find the other two that are missing. Okay, here we go. Saddle up. This is the first real big bear of the night. And it all starts with this. Here's a four-term polynomial. I want to find all of the zeros. In fact, because it's a degree 3, or third degree polynomial, I'm expecting that there could be up to 3 potential zeros or x-intercepts. And they're telling me ahead of time, they're doing me a favor by telling me that x equals 4 is one of the zeros. Now, as soon as they said that, I said to myself, you know what? That means x minus 4 is one of the factors. Okay, and remember we said because it's a factor, we know that the remainder is guaranteed to be 0. So that's what we're going to do right off the bat. So we're going to do our long division, and we're going to ask ourselves, what do I get if I divide x cubed minus 13x squared plus 44x minus 32 by a factor of x minus 4? So let's go ahead and zip through our long division and see what we end up with. Okay, here's what my long division looked like, and we give ourselves a little happy face down here because I did get a remainder of 0. And I'll tell you what, if you get something other than 0 right here, oh baby, that's a red flag. That means we need to retrace our steps through the math here to figure out what went wrong. Notice here's my quotient. Okay, let's review the terminology again. X cubed minus 13x squared plus 44x minus 32, that was my dividend, okay? And the divisor was x minus 4, and I got x squared minus 9x plus 8. So let's rewrite that first and foremost as a quotient and see what it looks like. As a quotient, I'm going to say x cubed minus 13x squared plus 44x minus 32 divided by x minus 4 equals x squared minus 9x. Now, similar to the slide we did a few minutes ago, can we rewrite this quotient as a product? In other words, x cubed minus 13x squared plus 44x minus 32 equals the divisor multiplied by the quotient. And what you'll notice about this quotient right here, and this is what's special about tonight, is this quotient's factorable, which means we're going to factor it more than what it is already, and I believe I'm getting x minus 8 and x minus 1. Notice how the negative 8 and the negative 1 add up to negative 9 while multiplying to a positive 8. And now that I've got it completely factored, I can use the zero product law, in other words, teeing it up here, and I'm going to get x equals 4 as a 0. I already knew that one because they gave it to me. But also x equals 8 and x equals positive 1 are also zeros. So now that I know where the x-intercepts are, I could analyze the end behavior. I know that this function's an odd degreed function here because of the 3 positive leading coefficient. I know that I've got a graph that's going to start low, finish high with 3 x-intercepts. Very, very similar example. I wouldn't say that this one has any higher degree difficulty. It's just going to be extra practice for us to get another one under our belt so we feel a little more comfortable walking into class tomorrow. And right off the bat here, if x minus 1 is a 0, then we automatically know that x plus 1 is one of our factors. And because it's a factor, we're guaranteed to get a remainder of 0 when we do our long division. So what's this going to look like? We got x plus 1, and my dividend is x cubed minus 8x squared. How about this? As I'm getting it set up, ask yourself, do I agree that factor by grouping would not work on this one? That's always an option, because I tell you what, if factor by grouping works, then by golly, we're better off doing that. But I don't think it will. So let's go ahead and whip through our long division. Whew, check this out. Man, that was some intense long division. Again, happy face down here. We got a remainder of 0. If you don't get a remainder of 0, then by golly, work your way back through here and figure out what went wrong with our adding or subtracting. My quotient is x squared minus 9x plus 18. So my goal now is to rewrite the entire problem as a quotient. Let's see if I can slide the screen here a little bit. Okay, so as a quotient, we could say x cubed minus 8x squared plus 9x plus 18 divided by x plus 1 turned out to be x squared minus 9x plus 18. Now let's rewrite the quotient in terms of a product. We know that x cubed minus 8x squared plus 9x plus 18 is equal to the divisor multiplied by the quotient. Check this out. What makes today special is that my quotient is factorable. So let's take that a step further. I need two numbers that add up to negative 9 and multiply to positive 18. And I think I'm going to go with negative 6, negative 3. Now that the polynomial is completely factored, I can tee it up. X equals negative 1. I already knew that one. But also x equals 6, x equals positive 3. And we could really come up with a really good graph now that we know the x-intercepts here. We know the end behavior of the graph. And if we needed more detail, if we wanted to know whether the graph bounces at 6 or crosses the x-axis, that's where the sign chart is going to come into play and determine whether the graph's above or below the x-axis. So I hope you've enjoyed the factor theorem, and we're going to be ready to kick some butt when we come in tomorrow.